Welcome. This is David Amos Brown. This video will get you started navigating the AOS system to explore it and try a few things. What we're looking at is an AOS Central Library interface. So let's begin. As discussed in the overview video, AOS only has user interfaces and software controls that go on those interfaces. Windows in Microsoft Windows are also called forms and are how we see applications. Forms are independent and can move freely on any of the available screens. Forms appear on the taskbar and minimize, maximize, and normalize. In AOS, those operations are done with slightly different user actions. We will use the term AOS form to denote an independent AOS window, but AOS forms are also interfaces to us. Clicking the logo on an AOS form minimizes it. Right-clicking on an AOS form header address banner will toggle between normalized mode and maximized mode. All AOS forms have two regions, a header that has program-related settings and required buttons, and an interface for programs. Some AOS forms are program environments like user applications and process tasks, while other forms are control panels for doing design work like the Data Explorer shown here. AOS forms can be forced to close by right-clicking in the taskbar and selecting Close Window. AOS is a hotkey environment, which means that everything is done by keystroke or mouse. The AOS keyboard has been carefully designed to be as universal for all AOS controls and AOS forms as possible, and as memorable as possible. All controls have a right-click context menu that lists all the keystrokes, mouse movements, and their operations for that control. Some of the menu items can be selected to perform the listed operation. Let's look at one. We select the Settings Assembly and right-click. As you can see, there's a lot of information here, and that AOS pretty much utilizes all of the keyboard. All context menus have two sections. The top section is specific to the control you're looking at, and the bottom section is for all controls, and pretty much covers positioning and sizing, saving and loading all controls. Let's look at F7 to see how to read this. F7 is used exclusively to add things to other things. So we give it an AOS name called add, as you can see in the parentheses. For an assembly control, there are three variations. If I want to add a control to an assembly, from the tree, I press Ctrl F7. If I want to add a control to an assembly from File, I press Shift F7. And if I want to add a function control, then I press Alt F7. Because AOS is an operating system with control panels, the root form on an AOS computer is designed to act like a desktop, and is a program environment itself. When maximized, all other AOS forms will appear on top of the AOS root form so the user can see everything AOS. Think of it as a divider between AOS forms and Windows forms. When you're in AOS, all of your AOS forms are on top of the AOS desktop. When AOS is not the active application, all AOS forms except the Data Explorer are designed to hide themselves. Programs on the root form will most likely be targeted towards the whole AOS machine operation and are saved with the computer environment. The root form has settings that affect all of AOS on that machine, like the appearance of the control panels themselves. The entire appearance of AOS can be customized like the AOS logo to your own logo. There are 5 major control panels used to do programming work, and a number of minor control panels like the color and font selectors. We will call the 5 main ones design panels. Since AOS only has AOS forms and AOS controls, and we're looking at the AOS root form, let's do the next logical thing and add a control. F7 is the universal AOS add key. On an interface, it calls up the first design panel, the control selector. There are 2 fundamental types of AOS controls, program controls and expression functions. Program controls go into program environments, and function controls go into expressions. You can add a function to a program environment if you so desire by pressing Alt plus F7, but it will be a manual function because there is no expression to tell it to execute. F12 is the AOS program key. Pressing F12 on a function will cause it to execute. We've added an extended video control because we have a programming example to discuss, and it allows us to call up the next design panel, the Interface Settings Editor. Pressing F4 on a control brings up the Interface Settings Editor, which contains the appearance settings that are common to all controls. Then, if we press Control plus F12 on an extended control, it will call up the next design panel, the Tree Editor. The Tree Editor gives us access to a control's driver values. The Tree Editor is also used to edit a table's fields when Shift plus F12 is pressed. Here you see the control's driver values are divided into common categories like visibility, status, and art. When we want to express one of those driver values, we select it and press Shift plus F12, which brings up the next design panel, the Expression Editor. The Expression Editor allows us to add all the functions we need in our expressions. And finally, when we design expressions, we are needing functions, data, data addresses, and trigger addresses, and they are provided by the last and most important design panel, the Data Explorer, which is really 4 different types of explorers: a Control Explorer, a Data Explorer, a Data Address Explorer, and a Trigger Address Explorer, depending on the data type being edited. So let's recap. F7 on an interface to add a control with the control selector. F4 on a control to edit its appearance with the Interface Settings Editor. Control plus F12 on a control to get to its driver values with the Tree Editor. Shift plus F12 on a value or list type of control to express it with the Expression Editor, and the Control, Data, Data Address, and Trigger Address Explorers allow us to complete our expressions. Now we're going to go get our example video with F7, Add a Video. Before I narrate this video, I'll show you all of the design panels in action in the smallest useful program I can think of. I'm going to put a Go button on the interface so I can start the video with that. The extended video control has a play button driver which can be used manually or expressed. We're going to express it so we can trigger it with the Go button. Since buttons don't really have a value unless the text on the button is desired, all we have to do is provide a trigger address. When the expression evaluates, the button is pressed. Now I can put all these design panels away, size the video for discussion, and then use our first one expression program. And away we go. We're going to create a custom 4-button calculator that is better suited to our personal needs. Most calculators have only one place for displaying both input and output, which means you can't see everything at the same time. That's not ideal if I get interrupted a lot. So I want to see all the information that goes into a calculation and therefore need 2 inputs and 1 output, and since we're separating the inputs and output, we need a continue function to put the current result into the first input when we're doing progressive calculations. Here you can see we've added the necessary controls to our application's interface. We added a label with a reserved name so we can drag our application around. We added the 2 inputs, 4 function buttons, and the 1 output, along with the continue button I mentioned. Then we decorate the application with the Interface Settings Editor. We're setting colors, masking out headers that are not needed, and setting control positions and sizes. Here we're setting input 1's background to light blue. Then we mask out input 2's header, set its background to light green. We want the function buttons to be in a line across the application, so we put 3 of those in line. we mask out the header on the result. And then finally, we need our application name in the header, and then set up the application to hide the editor header when in use and panelize the interface for a professional look. And there's our nice little custom postage stamp calculator per our design. We're going to add some data to the input so that we can test our expression as we make it, and then express the calculator output. In AOS, expressions evaluate when the data changes at one of the trigger addresses. When that happens, the address that changed is put into current trigger so that the functions know what to do. Then the functions are executed from top to bottom, the last one retrieving the expression's final answer from its location. Here you can see that the current trigger follows the button presses. To be able to apply different math functions to our output, the decision function is needed. A first match decision function gets a test value from a selected location and tries to find a branch that has a matching value. It looks at each branch in order, and if it finds a matching value, it executes the functions in that branch and transfers the branch's result to its output. The decision function is what makes programs intelligent because, just like you, the decision function can look at its environment, assess what's what, and decide what to do. A pinball machine is a fun way to think of an expression evaluating in AOS. The ball drops down hitting every function, and when it hits a decision function, it rolls across the top and falls down the matching branch. Every function it hits is executed. That, coupled with the fact that expressions evaluating in a program look just like falling dominoes, and that your program's data environment is a pure tree, it's easy to visualize what's happening in your program in AOS. Clarity in the programmer's mind is the most important thing because that's what is recorded. If you're not clear, how can you tell the computer what to do? This is true for all software creation. Think 9, do 1 is a good guideline. Here you can see we've added the decision function, gave it a numeric output called final answer, set where the test expression gets its information, and then started adding the matching values and math functions to each of the branches. Each branch is told where its final answer is so that if that branch is used, its result will make it to the output. The things we do in AOS are real programming methods. They are the same things we do in contemporary software. AOS just looks different. We can take any piece of software and build the AOS equivalent. It will work the same way, just slower, because AOS handles everything computer-related, allowing the programmer to focus on nothing but his or her pure informational solution. Think of AOS as a bubble inside the computer around the programmer. Outside of the bubble are all the horrible computer constructs like TCP/IP, which requires a 3-volume set of books just to describe how to move information around the planet. Inside the bubble is pure information and what the programmer does with it. What you learned in high school was the theory and application of information. Bits and bytes don't even exist in our human world. Bits, bytes, and all the technical computer stuff are simply a means to an end so that we humans can use what we already know when we're inside the computer. And here you can see we're finishing up the divide branch. We've added the function, and now we're telling the divide branch where its final answer is. Then the expression result, which is the final function, is told where its answer is. And there is our functional calculator. To finish up, we express the input 1 so that we can go get what's in the result when the continue button is pressed, and voila.